All right, so today's notes are on standard form of quadratic functions. Our content objective is to write quadratics in standard and vertex form, and our language objective is to use correct terminology to describe quadratics and their graphs. First thing I want to refresh your memories are the forms of a quadratic. So we had vertex form, which we practiced or worked with last time, factored form, which we worked with during Unit 4A and then again in 4B. Now, standard form, you've seen it several times. That's where you start before you factor, but we're going to be focusing on standard form in relation to graphs and vertex form today. So today's focus is going to be on standard form. So that's where we're going. So first thing I want to refresh your memory on is the axis of symmetry. So we talked about this last lesson. In vertex form, our axis of symmetry is just x equals h. So if we're talking about vertex form, h is here, x equals h is our axis of symmetry. It's the x equals the x value of the vertex every single time. In today's lesson, our axis of symmetry is going to be x equals negative b over 2a. So that's what we're going to be using to get our graph from standard to vertex form, is this similarity. So I can say that h is equal to negative b over 2a, and that will help me create vertex form. So we're going to start in our first example, converting standard form to vertex form using this bit of information that I just mentioned. So since I know the x value of the vertex will be negative b over 2a, I can use that to build my vertex form. So first example, converting standard to vertex form. What is the vertex form of 2x squared plus 10x plus 7? So the first thing I want to do here is identify a and b. So because I need to use negative b over 2a, I need to know what a and b are. So a in this problem is 2, b is 10. So again, a is the coefficient of x squared, b is the coefficient of x. Then I'm going to solve with h, or step 2, I'm going to solve for h using h equals negative b over 2a. So I'm going to say h is equal to negative 10 over 2 times 2. So I'm just plugging into this formula, which says negative 10 over 4, or negative 5 over 2, or negative 2.5. I'm going to use decimals for today, just because I think it's visually easier, but you could have left that in fraction form as negative 5 over 2 if you prefer. So now that I have h, I still need to find k. So if I'm looking back at vertex form, I have h, I need k. One helpful thing is a in all three forms is always the same. So you can make a little note of that. So you never have to solve for a. A is the same value in all three forms. So a is not going to change. So I know a is going to be 2. I know h is going to be negative 2.5. I just need k at this point. So I only need to find k. So the way I solve for k here is by substituting my x value into my original equation, and that will give me k. So substitute So if you think about it, if you know the x value of your graph and you want to find the y value that goes with that x value, all you do is plug it in for x. This is true whenever you're finding an output for a given input. So I plug in my input to get the output, which will be my k. So since I know this is the x value of the vertex, if I plug it in, it will give me the y value. So that's what I'm going to do. So I can say y, or k, however you want to write it, equals 2 times negative 2.5 squared plus 10 times negative 2.5 plus 7. And when I solve that out, you can use a calculator if you want, but I would get negative 2.5 squared times 2 is positive 13.5 minus 25 plus 7, which turns out to be negative 5.5. So if you want to double check my computation, by all means, you can do that. But y, or k, equals negative 5.5. So my last step is to substitute into vertex form. So now I know H, I know K, so I can note these if I want. So H equals, K equals, A equals. I have all three values I need to write vertex form. So I'm going to go ahead and write it. And I can say Y equals 2, since that's my A value. X minus H, but since H is negative 2, I switch, or negative 2.5, I switch the sign. It'll be plus 2.5 squared minus 5.5. And that's my vertex form of the quadratic. In standard form, y equals 2x squared plus 10x plus 7. So I'm going to flip the page for a quick check really fast. So I'm going to flip the page for that. So our quick check, I want you to try this one on your own. I want you to write what is the vertex form of y equals negative x squared plus 4x minus 5. So try it on your own. Pause it if you need to. I'm going to go over it now. So I know my A value is -1. I know B is +4. So if I can say H equals -4 over 2 times -1, that's going to be -4 over -2, which is just going to be +2. So I now know my H value is 2. So H is 2. I have that. I have my A. I just need my K. So all I'm going to do is plug that into my original. So I get y equals -2 squared plus 4 times 2 minus 5, which is going to be -4. Since that negative is in front, keep in mind that's your A value. It's in front. It's not squared. -4 plus 8 minus 5, which gives us -1. So I can say K is equal to -1. And I now have my AH and K values, so I can write y equals negative parentheses x minus 2 squared minus 1. Don't forget to write the squared sign. A lot of people forget that when they're writing it, and that would be a linear equation, not a quadratic. All right, so the one other thing I want to talk about today is going the other way. So converting vertex to standard form. This one is a lot easier in my opinion because all it is expanding and foiling. So I'm not going to do a quick check. I'm just going to do a quick example. What is 2x minus 1 squared plus 3 in standard form? So our steps here are going to be 1, expand the binomial squared. So one thing I've been trying to emphasize, but I know people will forget, you cannot distribute this exponent because you're adding and subtracting inside. So I'm going to expand x minus 1 plus 3. Step 2 is going to be to distribute binomials or FOIL. So I'm going to FOIL those binomials. So I have 2 x squared minus x plus 1 plus 3. If you want to combine like terms, you'd get 2x squared minus 2x plus 1 plus 3. Step 3 is going to be distribute A. So I'm going to distribute A into each part of that. So I get 2x squared minus 4x plus 2 plus 3. And last step, combine like terms. So if you didn't combine these and you just distributed the 2 and then combined them, you would end up with the same answer. So it's all fine whenever you distribute the A, whether you combine in the parentheses first or second, it won't matter. You should end up with y equals 2x squared minus 4x plus 5. And that would be standard form from vertex form. So I'm not going to do a quick check for this one. The only other thing I want to note is whenever you're finding a maximum, so this is going to come up in a lot of modeling problems, and I'll bring this up again then, but maximum minimum, and this means max is always the maximum or minimum of a quadratic will always be the vertex, which you can find with x equals h. It's always gonna, if the maximum of a quadratic will always be the vertex. So you can use x equals h or x equals negative b over 2a and then find your k or find the y value of the vertex. So whenever a problem asks you to maximize or minimize, it's asking you to find the vertex. So if it's asking you to maximize or minimize, it's asking you to find the vertex since the maximum or minimum will always be the vertex. So I'll bring that up again later when we talk about modeling problems, but it might come up in some of today's stuff. So I just wanted to point that out. All right, that's all for today. Make sure you write down any questions, comments, or concerns so we can go over them together in class.